Do you find math or science difficult or challenging, or you want to upgrade your matric? Krazifizix is your answer. The home of quality and inspired teaching of math and science. We offer the best service in teaching and simplifying concepts with fun and easy to remember dynamics. No one does it better. Many have had their dreams set in motion under our tutelage. We want to be part of your success story. We offer both actual and virtual tuition and homeschooling from grade 10 to 12. Are you working but need to upgrade your matric? Trust me, we got you covered, holding your hands till you make it for your matric upgrade wherever you are in South Africa. Our cloud and remote resources are adequately prepared to take you through every concept in detail. Simplified explanations, simulations to make you enjoy science and have fun with it. Textbook, workbooks, plug and play on the go class would also assist you as part of our resources. Why don't you just subscribe to our YouTube channel? Don't forget to hit the like button. Krazifizix or Crazy Edu TV. Register now for 2021. Send us an email at info@krazifizix.org.za. You'd never go wrong with us.
Hi, welcome again. This is Krazifizix grade 11 and maths, quick maths revision. And this is our Algebra B. Remember, if you have the first one, it is part A, and we are trying to break it into small concepts. Okay, so we go for the next set of questions. What did we do in the first lesson? We did all of this trying to solve for x. I hope you had a lovely time revising. Okay, and now we want to deal with our simultaneous equation and a little bit of search there. Let's reproduce this page as well so that it becomes easy. Okay, simultaneous, very important and easy marks to get. All right, very easy marks to get. So we have y minus x plus 1 equals to 0. Okay, equation 1. X squared plus xy equals to 3. Equation 2. Always work with the simpler equation. If I compare 1 and 2, I think 1 is a lot easier. Now, find either y or x. There is no rule that says you must find x first or you must find y. No, there is no rule. Just look for what works for you, what's simple. I could then move the whole thing and leave my y. My y is already positive. Let's work with that. That's simple. All right, if I move the x over, it's minus x, it becomes positive. If I move the 1 over, it becomes negative. You're done. Equation 3, make life easy. What do? We substitute equation 3 into, anywhere we see y, we write x minus 1. So it's x squared plus x into bracket, y minus 1 equals to 3. Now, we substitute y is x minus 1. I was wondering. We're supposed to have a single variable across. Okay, so it's x squared plus x. My y is x minus 1. All right, let's expand that. X plus x squared will be 2x squared minus x. Now, if I bring the 3 over here, it becomes that. Again, we have a trinomial. Make sure it is written as a standard form. From here, you can solve whichever way you want. You can use a quadratic, you can use your normal factorization, but for the sake of learners who are struggling with factors as well, okay, this time around, I did quadratic in the first video. Let's try to factorize here. There's a particular method that I like. Let's go check it out. So I'm going to do this, x squared minus x minus. Now, someone's saying, but that's a 2. I didn't make a mistake, don't worry. I am going to multiply that 2 and that 3, which gives me a 6. I just like this method. I'll tell you why I like this method. I like this method because it automatically takes away the coefficient of x that is greater than 1 and leaves it as 1. So you saw what I did? I multiplied my 2 and my negative 3. Watch this. I'm going to use that information again. I'm sure here we can all factorize this. That's baby factorization grade 8. X minus Okay, now before I put minus, I want factors of 6, but I want to get 1. All right, my factors of 6 would be 6 and 1, 2 and 3, and what? Yeah, that's all. Those are the things that will give me 6. All right, but I want to get 1 when I add. So 2 and 3 would be my ideal values, 2 and 3. But I want a negative 1. How do I get a negative 1? Plus 2 minus 3. Awesome. Now remember, we're not done. Don't just say x equals to 2, x equals to 3 here. No. Now remember that I multiplied earlier on by 2. I am going to reverse the whole situation and divide my constant values by 2. I multiplied by 2, I reverse and divide by 2. All right, what's my answer here? X plus 1. Now check this. 3 over 2, we want to try to get a whole number. That's the whole idea here. So I'm going to bring this 2 here and write it like this, 2x minus 3. So basically I'm getting rid of the fraction. And I'm done. That's my factorization. Quite easy. Okay, so it's either x plus 1. You need to rewind that, please. All right, I'm moving quickly because of time. What's my answer? X equals to negative 1 or 2x equals to 3, and that x is that. You see, I'm coming back to all of those there. All right. Now, I have gotten my x, but I need to get my y. You don't need to go back to the first equation. Go back to the second one that is already simplified and substitute. When x equals to negative 1, what would I have? Minus 1, and y equals to 2. Done. What about when x equals to 3 over 2? What would I have? Y would be, my x is 3 over 2 minus 1, and my y will be positive half. And I'm done. 6 marks in the bag. Lovely. 6 marks in the bag. Use a calculator if you have to. Use quadratic if you have to. Do whatever that is right that works for you. It's not about being smart. It's about getting the marks now. Okay. Maths is just routine. It's a repetition. Let's see this. We want to simplify. Now, there are different ways of doing this. I'm going to try different methods. Let's see. You choose which one works for you. You choose which one works for you. I'll try about 2 for time. I could try a lot more. Now, what I would want to do first is, since I am multiplying, understand the rules. Understand the rules. Square root of AB is the same thing as square root of A. This is grade 8. All right. This is grade 8. So let's use this particular one first. So this means square root of 16 times square root of x to the power 7 minus, why am I breaking it? Because I see perfect squares here. All right. Over square root of x. Oh, my square root of 16 is 4. So this is basically 4. And, okay, I can still do this. Let's still leave it this way. Just want to make sure I'm carrying everybody along. All right, look at x to the power 7, x to the power 7. They are like terms. All right, so 4 minus 5 is minus 1. Minus x to the power, okay, 7 over 2. Somebody's saying, but where is that 7 over 2 coming from? Remember that, let me use a red here, x, p, and a. All right? My x to the power of p remains. That a outside becomes a denominator. So it's x to the power p over a. And the number outside is a 2. So if I have a root of x to the power 7, there's a 2 here that we don't write mathematically. So x to the power, my 7 is still there. My 2 then comes in. Sorted. Minus 5, x to the power 7 over 2, divided by x. No. My 5 is gone, by the way. Oh, I was repeating steps. Sorry. Now, remember we said 4 minus 5 is negative 1. Okay. Let me just, so this would have been equal to minus x to the power 7 over root of x. Okay, so that's what I have. That is what I have. And this x root of x is the same thing as... Now, laws of exponent, the first ones, when we are dividing with the same exponent, what do? We subtract the... dividing with the same base, we subtract the exponent. So it's 7 over 2 minus 1 over 2. And that will be negative x. If you use your calculator there, it's going to give you 3. And that's my answer. I can no longer simplify further. Let's try another method quickly. You need to rewind, but let's just show, like I told you, there are so many different ways. Make sure you're using the correct maths principle. That's what matters. In order to get rid of my denominator, you know what I would do? I would rationalize. What is rationalization? Multiplying across. All right? Let's see. You need to know this, because there are questions that will test this. I'm going to multiply that and that. All right, I'm rationalizing. What is the aim? The aim is to get rid of a denominator third. We don't want that square root as a denominator. So, remember, I'll have to multiply that and multiply that. What will this give me? This will give me 16x. Watch this. This is very, very important. X to the power 7 times x, because I am multiplying everything under the square root. The same thing we did here, we're reversing it. Whatever is under the square root, we multiply. So root, the root remains. Then we have a times b. So this is what I have. X to the power 16, x to the power 7 multiplied by x there. We multiply everything under the square root and keep one root. The same thing would happen here. 25 x to the power 7 times x over... Now, the same thing would happen here. Okay, but we know that root of x times root of x should give me x. Look at what I'm going to have. I would have square root of 16x to the power 8 minus 25x to the power 8 over x. Interesting. Very, very interesting. Let's get a fresh page quickly and move to nature of roots after this. So this is what we have. Let's get back to our traditional board system. There we go. How do I then solve this? Oh, what is the square root of 16? 4. Now, what is the square root of x to the power 8? It is x to the power 4. I just divide my exponent. Remember, remember this means 16 multiplied by x to the power 8. This one is 4. And this is x to the power 8 multiplied by half. In fact, that's how we actually got the 4 as well. So this is 4 squared multiplied by half. Remember, we can split. We split it. And this 2 times half would give me 4. 8 times half would give me x to the power 4. That's what we did. In the same way, this would give me 5x to the power 4. Oh, like terms, that will give me negative x to the power 4 over x to the power 1. When we're dividing with the same base, we subtract the exponent. 4 minus 1 minus x to the power 3. All right, I'm done. There are so many other ways that you could use. As long as your maths principle is correct, please go ahead. But learn how to rationalize. All right. Now we go to nature of roots. Nature of root. Okay, I don't need to move this, change this. The solutions of the quadratic equation ax squared plus bx plus c equals to 0 can be represented as x equals to minus b plus or minus our discriminant. All right? Plus or minus our discriminant. That looks more like a quadratic equation. So our discriminant finds itself under the square root. So my discriminant is b squared minus 4ac. For which values of the discriminant would the roots of the equation be real? Let's just quickly get something here. Roots can either be real or unreal. Roots can either be real or non-real roots. If they are real, my discriminant must be greater than or equal to 0. If they are non-real, my discriminant must be less than 0. Now, when they are real roots, there could be 3 types. They could be equal, so real and equal, real and unequal, real and rational. Now, if they are real and equal, we're just going to split this guy. That's all we're doing. We're going to split this guy here. That's our main game changer there. All right. If it's equal roots, then my discriminant must be equal to 0. If it is unequal root, my discriminant must be greater than 0. And if they are rational root, my discriminant must be a perfect square. Under functions, this is what my graph would look like. Let me draw graphs quickly. If they are equal roots, it will touch the x-axis just at one point. Doesn't matter which way. Doesn't matter whether it's on the x, on the positive x or negative x. Doesn't really matter, but that is what it will look like. All right. Remember, these are just sketches, so let me do this. Mustn't go above my y-axis. They are just sketches. There. Equal roots. That is only one root, but equal. Unequal roots. It doesn't matter. I could have that. 2 different points. All right, it will touch the x-axis at 2 different points. It could be both negative, it could be both positive. It doesn't matter, but as long as we have 2 points of intersection. It could be one positive and one negative. All right. So those points are called the roots, and they are unequal. This one would look like the equal one there. Okay, it will touch the graph just once. Doesn't matter where, it will touch the graph once. When it is non-real, it doesn't touch the x-axis. That's what we mean by no solution. It will not touch any of the graphs there. All right. So if I want to answer this question, for which values of the discriminant will the roots of the equation be real? I've already answered. My real root discriminant must be greater than or equal to 0. 1 mark, and I'm done. So it is your duty to remember this is a very short summary on nature of roots. So I have a question here that was set in a very, very unique way. So this is actually testing, do you understand what roots are in relation to functions as well? All right, the following graphs A, B, C of the function k of x equals to ax squared plus bx plus c are given below. Without solving for x, match the equations 1 and 2 with the correct graph based on the type of root. Show your calculations and state the reason. Oh, but they said we should not solve for x. Oh, let's look at the first one. We're not going to solve for x. Relax. For number 1, all we need to find is our discriminant. That is what determines my nature of root. Okay. Now for that, what is my b? My b is negative 8. Don't forget your signs. Minus 4. What is my a? My a is 1 over 4, and my c is 64. Let's throw that in a calculator quickly. But you can calculate, that will actually give you 64 minus 64. That will be 0. Do that quickly. Your discriminant is 0. Oh, if my discriminant is 0, what happens? They should be equal roots. Ah, and where are they equal? Graph C. Beautiful. graph C, my discriminant is equal to 0. My roots are real, and not just real, they are equal roots. Oh, so this is equation 1. And that's also rational. That is also rational. I'll show you what I mean by rational. All right, if I were to factorize that, I would actually get something squared. If I were to factorize the first equation there, I would get something squared. All right, let's see. What about the second one, number 2? Number 2. Let's see number 2. Discriminant equals to b squared minus 4ac. What is my b? My b is negative 2 squared minus 4. What is my a? 3. And what is my c? 4. All right, if you use your calculator here, that will give you 4 minus, what would that give you? 4 minus 48. That will give you negative 44. Oh, my discriminant is negative. If it is negative, the roots are, so discriminant is less than 0. The roots are non-real. If I were to solve this, I would get no solution. Your calculator would give you error. If it is non-real, here, my discriminant is less than 0. So these are non-real roots. So this is equation 2. Okay, for this one, discriminant is greater than 0. They are real and unequal. If you remember, we actually did a quick summary there, and that's it. That is it. All right, so it's quite easy to get through your nature of roots. It is very easy to walk around your nature of roots. Very straightforward. Let's go back to equation 1. If I were to factorize this, you know what I would do? Let's multiply equation 1 by 4. Just to show you something here, I'll get x squared minus 32x, all right, plus 64 times 4. 4 times 4 would give me 16. And then I have 24, I have 256. Okay, now if I want to factorize this, what would I have? Let's see. How do I get to 56? I see that 256 can actually be, what, 16 times 16? Yeah. Because I want to get 32. Okay, let me just show you. 16 times 16 is 256. Beautiful. So definitely this will be what? Negative 16 and negative 16, because I want to get 32 there. Okay, I'm trying to factorize. I'm using that first method. All right. Now, if you notice, I had multiplied by 1 over 4. You can divide by 1 over 4 as well. Doesn't really matter. Okay. Let's check something. That will be 64. So, but it's still fine like this. 16 divided by 1 over 4 will just make the answer become extra. That will be 64. All right. But anyway, we are perfectly okay with what we have done. X minus 16, x minus 16. Okay. X minus 16, x minus 16. Now, what do you notice? It actually gives us a repeated root. It is squared. It is squared. This bracket and the second bracket are the same. That's what we mean by rational. Remember we said it must then give us a perfect what? Square. It must give us a perfect square. We want to rewrite this as something we can divide everything just to get be able to get our 64 there, then it will be 8. So this would have been x over 2. I can rewrite this as x over 2 minus 8, x over 2 minus 8. That wouldn't give us our original equation, because x over 2 times x over 2 will be x squared over 4. Now, do you notice that this can be written as x over 2 minus 8 squared. Now, that is a rational root. My graph would still be C. Okay, my graph would be C. And that's just your nature of root. Once you get a perfect square there, it gives you a rational root. I think I have one more question that I want to play with here on nature of roots. Prove that the root of this is equal to 0. Please always make sure, okay, 2x squared minus k minus 1x plus k minus. Please, sometimes they give out that equation spread wide. Make sure you factorize x out because you want ax squared plus bx plus c equals to 0. They said prove that they are real. You need to find the nature of roots here. For something to be real, for real roots, okay, what should we get? Discriminant must be greater than or equal to 0. So let's go find our discriminant quickly. We're not going to equate it to 0. This is what we want to get. If my discriminant is greater than or equal to 0, then we say the roots are real. So let's go look for our discriminant. My discriminant is b squared minus 4ac. Beautiful. What's my b? My b is the whole of k minus 1, but it's negative, the coefficient of x. All right? Let me get a different ink here. The coefficient of x, which is b. And this time around, that is my b. So what do we have? Minus k minus 1 all squared minus 4. What is my a? 2. What is my c? My c is k minus 3, the whole thing here. Okay, that's my discriminant. Let's go simplify that discriminant. Okay, discriminant is negative squared will be positive. So basically, I am left with k minus 1 squared. Just to simplify, 4 times 2 would give me 8, and I have k minus 3. Beautiful. Let's simplify this. K squared minus 2k plus 1. I have simplified, remember, k minus 1, that's minus k multiplied by 2. That's how I got that. And minus 8k plus 24. So what do we have? K squared, what would that give me? Minus 10k, and 1 plus 24 would give me 25. Lovely. Let's factorize that. That will actually give me k plus, no, not k plus, k minus 5. Oh, so this is what? K minus 5 all squared. Beautiful. Since my discriminant is a perfect square, all right, remember that k minus 5 all squared will always be greater than or equal to 0 for all values of k. And when I say all values of k, that is including 0. Okay, including 0. Now, if k is equal to 5, this would give me 0. The whole thing would give me 0. So that is always, I told you, when the base is positive, those values will always be greater or equal to 0. K minus 5 all squared is greater than or equal to 0 for all values of k. Oh, so it means my discriminant is greater than or equal to 0. Therefore, my roots, remember they just said roots are real. They could be equal roots, there could be unequal roots, and there could be rational roots. This is nature of roots. Still, there are still more complex questions here and there, but the principle remains the same. I hope this session has been a blessing and it has helped you a lot. All right, I will catch you now in part 2, which will be dealing with our Euclidean geometry, the basic Euclidean geometry for grade 11 and 12. Goodbye, everyone. Krazifizix signing out.